And we're going to open up the floor for questions on the homework last night. The homework being in section 11.7. And so if you've got that in front of you, if you got your assignment in front of you, that'd be good. You can go ahead and share some of those questions with me. Now, Mr. Davis, which one did you want to ask about? You were, I think, one of the ones that had a question to begin with.
I think he just lagged out.
Oh, no. Well, that's no good. Anybody else have questions on the homework?
Can you do number 57?
Number 15.
57 and 15, I've heard both of those. And I'll tell you what, I'll try and do the earlier one first, the easier one first, before we get into one of the harder ones. And the rationalizing the denominators and the numerators and whatnot, that's something I haven't taught you guys just yet. So we're going to address that, Jack, in class today for sure. So like 57 is one that I wouldn't expect you to know how to do just yet. That being said, number 15, we should know how to handle this. Let me get my, so I can see you guys while I'm talking. There we go. Got you pulled up on my other monitor here. A problem like number 15, I would encourage you guys look for opportunities to simplify first, okay? Not that will always be the case, but it certainly is here in this case. We got the square root of 8/11ths, and we've got the square root of 22/32. So I'd simplify that second fraction first, okay? Simplify that second fraction, and in fact, Grady, you want to do that one for us, simplifying that second fraction just real quick? Booth, you got to unmute your mic.
11/16.
All right. Now, 11/16, I like that because now what we can do is we can combine these two. The radical of a product is the product of radicals and vice versa. You remember from our previous lesson where we had the basic tenet that the square root of AB is the same thing as the square root of A times the square root of B. That works in reverse also. If I want to multiply two radicals, as long as the root's the same, just multiply the radicands. Okay, so this becomes 8 times 11 over 16 times 16. And we could do some simplifying out, right? Wait a minute, I screwed that up. Sorry. Y'all yell at me when I do stuff.
8/16.
Yeah, I know. I messed that up. It's 8/11. 8/11, 8/11. I knew my 11s were going to cancel out, and there's just transcription error on my part. So the 11s do cancel out, as do the 8s. So we got, this winds up being the square root of 1/2. The square root of 1/2. Now, at this point, right, you would split it up and say the square root of 1 over the square root of 2. What's the square root of 1?
1.
It's just 1. And at this point, you guys have not talked about, so this would be an interesting time to segue into this notion of rationalizing the denominator. You haven't really talked about having a square root in the bottom of a fraction, okay? So first things first, in your notes, can you write down that that's considered to be bad form? It's very unconventional. We don't leave a radical in the denominator of a fraction. It's considered bad form, right? So I need a way to get that radical out of the denominator. So what we're going to do is we're going to make use of a clever form of 1. We're going to make use of the old trick where you could just multiply by 1 whenever you want to. That's our multiplicative identity property, right? So check this out. I'll do this one for you guys. I'm going to pick a fraction to multiply this by that equals 1. Now, I could pick 5/5, or I could pick 6/6, or I could pick 7/7, and all three of those fractions would equal 1, and they would be legal and legit. But I'm going to pick a special version, which is square root of 2 over itself, square root of 2 over square root of 2. Okay, and what that's going to do is it's going to square the bottom. In other words, square root of 2 times square root of 2 becomes 2. And then up at the top, we multiply the top with the top and the bottom with the bottom, and we wind up with square root of 2 over 2. That's what's called the rationalized form of 1 over square root of 2.
Mr. Morgan?
Jack.
So the square root of 1, couldn't it also be -1? How would we do? We just not put
Square
that?
roots square roots by definition are always non-negative. So like the square root of 9 is 3. The
Oh.
square root of 25 is 5. The square root of 1 is 1. Now, if you had, Jack, if you had like the equation x squared equals 1, then you're absolutely right. You would say x equals plus or minus 1. But that if I just gave you the square root of 1, then that would equal 1 and only 1.
Okay.
Right? Okay. Hey, while we're on this topic, let's scroll down and actually I've got it in this section right here. Want to get down to it. Aha, perfect. I want to talk more about this notion of dividing radicals. So hey, in your notes, let's jot down. We got 3 examples right here to practice that notion with. Okay, and this follows along with example that not identically following along, but structurally. If you look on page 538 at the top, 538 example 3, this is going to kind of be similar to those examples. I'm gonna take a little bite real quick. You guys can jot these 3 down. My wife told me not to eat during class, but I couldn't resist. All right, so for this first one, the problem is that there's a square root of 3 in the denominator, and I really would like to get rid of that by moving it up to the top. Okay. Hey, you getting a cookie? Okay. So what would a clever form of 1? Campbell, can you pick me something to multiply this guy by such that my square root of 3 is going to be out of the way? What do you think, buddy? Ooh, I see you talking. I don't hear you talking, though. Your mic might be messed up. Sorry, man. Maybe you can get it figured out. You can hear me, I'm assuming. You just can't. I can't hear you. Okay. Let's see here. John, you want to take a stab at this? What do you think might get the job done here? Good one. For getting rid of that square root of 3. John, are you with us? Your mic's muted, so you might want to unmute your mic. I'll give you a hint. It's going to be a square root over a square root. What do you think, John?
Square root of 3.
Dude, very good, very good. Thank you. So that's square root of 3 over square root of 3. Okay. And again, we just multiply top with top, bottom with bottom. So in this case, I got 4 radical 3 because 4 is that coefficient. Just multiply him by the coefficient of that radical 3, which is 1. 4 times 1 is 4. And then the bottom, what do you think, Stephen, the denominator is going to be on this one? What's square root of 3 times square root of 3?
Oh, that would be 9.
It'd be what?
The square root of 9.
Attaboy. Square root of 9, which we know to be 3. And now this is in a much better form. Okay. Now, fellas, I'm going to pause right quick and say, this may seem like just nitpicking. Okay. It may seem like splitting hairs, this process of, quote, rationalizing. But you should know one thing that I've taught over the last, 14 years has also, other than Algebra 1, I've taught trigonometry and calculus. And in both of those classes, okay, it's a vital skill set. Not necessarily to take something out of an inappropriate form. Like that, logistically, there's nothing different about these two numbers. These are the same numbers, okay? That's like saying, 5/10 is the same thing as 1/2. It's just one of them is more acceptable as a form of writing your answer. But outside of that context, this skill that you guys are practicing with me today is going to be really important in some of those later classes, wherein maybe you're taking the integral of something in calculus, or you're trying to evaluate a trig, an inverse trig function, right? And maybe you're dealing with like 1 over the square root of 2, and instead you want to be able to operate with it as square root of 2 over 2, where this one might play into a little bit more, or like in calculus today, as a matter of fact, earlier today we were doing some limits, and one of the workarounds that they had to deal with was they had to rationalize the numerator of the expression. So on a real basic level, you guys here in Algebra 1 are learning something that you'll use, again, in some subsequent years, okay? Now, check this out. We've got square root of 3 over square root of 20, Okay. And I want to simplify the square root of 20 first. I'll ask Nick, can you do that one for me in your head? What's the square root of 20 going to simplify out to be?
2 square roots of 5.
So we got square root of 3, and then we got 2 square root of 5. Very good. He took out a 4 from the denominator. Now, think about this. What clever form, Aiden, would you use now to get rid of the radical in the denominator?
2 square root of 5.
All right, now interesting. That will get the job done. If you heard what he said, 2 square root of 5, that will get the job done. But the 2 is going to be unnecessary, okay? And this is where I start throwing a little bit some deuces your way. I start throwing a little curveball your way, all right? Because it's not, I don't want you guys just to be monkey see, monkey do, okay? Monkey poop all over you in that case. Instead, you want to think about, all right, how did he use the clever form of 1 in the first example? And will that work in the second example? Is there a better way in the second example? So like, instead of just saying, hey, just identically copy what's in the denominator, you know, in this case, we didn't. We just dealt with the radical because that's what we needed to do to cancel it out. Now, when I multiply top with top, bottom with bottom, I'm going to get the square root of 15, and I'm going to get 2 times the square root of 25, which is 2 times 5, which is 10. Okay, and again, the radical goes away. Matt Davis, are you back online with us now?
Yes, I'm here, sir.
All right, sweet. So like what we're doing, Matt, is we're kind of talking about number 15 from the homework, and it sort of spurred on this conversation about rationalizing the denominator. Matt, I'm gonna kick it over to you for this part C right here. Okay, what would you like to multiply by as far as your clever form of 1 is concerned? What do you think will get the job done for us?
You multiply it by square root of 6x.
Very good. Square root of 6x over square root of 6x. Now I'm going to do top with top, bottom with bottom again, right, guys? And so it's just 3 square root of 6x. Again, because the outside times the outside, the inside times the inside. And then down here, this is just going to end up being 6x. And then what do you notice, Gannon, that I now need to do at the end of my problem in this case? I haven't had to do this yet, but in the orange one, I'm going to have to do this. What do you think, Gannon? Herndon, you with me, buddy? You got your mic unmuted?
Oh.
Perfect. There you are. All right. What do you want to do to this fraction?
Would it be cancel?
Very good. We're going to cancel a common factor. Look at that. Numerator's got a factor of 3 in it. Denominator also has a factor of 3 in it. So how about we simplify the fraction at the end? So we got square root of 6x over 2x by just taking out that common factor of 3. Okay. Now, Will Perrone, why don't I do the same thing with the x? Why don't I cancel the x out? I see it's on the top and the bottom. What do you think? Perrone, you on here with us? Well, I don't know if he's on or not. I'll throw that over to Stovall. JT, what do you think, buddy?
Because the x is being squared.
Not being squared, it's being square rooted. It's inside the radicand, in other words, right? So like we can't simplify something that's on the outside at the bottom and that's on the inside at the top. It's got to be like the way that Gannon did it was perfect because we saw the 3 and the 6 to cancel those out, right? And so we didn't want to break any rules trying to cancel out the x that's on the inside. Right?
Why wouldn't you, when you multiplied the square root of 6x times the square root of 6x, and you wouldn't get 36x squared?
You'd get the square root of 36x squared, which when we simplify that out, square root of 36x squared winds up being 6x. We don't need the absolute value there because x was already originally in the radicand by itself, and there was an implied domain restriction that, I can't take the square root of a negative, therefore x is non-negative, so I don't need the absolute value bars there. Does that make sense, Anthony?
Mhm.
Good. Fabulous question. Hey, I thought maybe I was going to get another question. I've been kind of waiting for it. Nobody's asked it, so I'll go ahead and ask it. Have you noticed the difference in like how we multiply the numerators between the orange example and and the blue example, right? The orange example, the 3 he just sat on the outside of the radical. He didn't do anything. He was just sitting right there. Whereas the blue example here, these two radicals, they got it on, they mixed together to make square root of 15, right? And again, that's because we're multiplying radicals. And so as long as the roots are the same, you multiply their radicands together. 3 times 5 made 15. Down here in orange, there was no radical, right? So we didn't multiply by anything. It just stayed as the square root of 6x. Okay, so that's an important point to be brought up there. All right. So I'm going to introduce a couple more curveballs to you as far as rationalizing goes. And then, Jack, I think we've probably helped with 57 at this point, by the way. All right. So I'm going to go. These are not C-level questions anymore. These are going to be D-level questions. I'm gonna jack up the difficulty level on you guys and see if you can rise to the occasion. Okay. So you look at part A right here with me, and remember my silly little expression earlier. I said monkey see, monkey do, monkey poop all over you. If you try just to mimic what we've done thus far, what would you probably, if you were going to try just mimicking, what would you guys probably say multiply by on my clever form of 1 here?
6 square root.
Say that again. Let's say it properly.
Oh, 6 to
the what kind of root? The
cube root.
The cube root of
6.
6. Okay. So a lot of people think that, and that's the wrong answer, but it's the wrong answer. All right, because it's going to help us find the right answer, if that makes sense. Okay. So like you try stuff out, you do trial and error, right? I think maybe it was either this class or maybe my earlier class today where we're just trying something here. Okay. Multiply the top with the top and you just 1 times cube root of 6. That's easy. That's just cube root of 6, you know. But what do I get down at the bottom? And please, please, please be careful when you answer this. Okay. So what do you think, Wilson? What do you think, Wilson Webster, that you'd get when you multiply the bottom on there? Cube root of 6 times cube root of 6. And Wilson, you want to unmute your mic on that? There you go.
I did.
What do you think?
Would it be not cubed root, but like the 3 is a 9 root of 6?
Oh, that's not a bad guess. Remember when we multiply radicals, if I've got the nth root of a times the nth root of b, that's going to be the nth root of a, b. So like the root's going to stay the same. This is going to be a cube root. And so that's not necessarily going to be the issue. But that's not a bad guess. What do you guys do when you're multiplying 6 times 6? Does that root go away? Is it just gonna be the cube root of 36 and that's just 6 and oh happy day, we're good to go and problem's over? Anybody? Does that look good to y'all? Pack it up, go home, we're happy?
No.
No. Because we're dealing not with a square root, but we're dealing with a what?
Cube root.
A cube root. Now, if you think about the little jailer approach, you guys remember how I mentioned that, right? Like if you think about the jailer approach, what does the jailer here require? He requires 3 identical factors. Right now, how many does he have?
2.
He's only got 2. We started with 1. There was 1 6 to begin with, and then we gave him another 6, and he's only got 2. Okay, so like in the earlier examples, man, that was hunky-dory. We were gravy. Square root of 3 times square root of 3, that was square root of 9, and we were solid. We moved on. Square root of 5 times square root of 5, that's square root of 25, we were solid. We moved on. Here we can't move on because we have not given him enough. So can you amend what we multiplied by? Our clever form of 1 was, what should we have multiplied by? Not the cube root of 6, but the cube root of what?
So if we have this essay due, right? And me and Corinne, we were talking about it, we took the full 2 hours. I got a 7 out of 10.
36.
Cube root of 36. I think I'm listening to Miss Davis talk right there. Cube root of 36, because now the jailer is going to be satisfied. Now he's got all 3 of those 6s right there. And in other words, the cube root of, and I don't know what 6 times 6 times 6 is, but the cube root of 6 times 6 times 6 is just 6. and then the numerator winds up being cube root of 36. Okay, so that's a trick. That's a little curveball we throw at you, right? To where you're rationalizing a cube root. Okay, forget these other two examples. Let's do another cube root one. Real simple right here. What about 1 over the cube root of 4? 1 over the cube root of 4. What would it take there, Thomas, to satisfy the jailer? In other words, to get that radical out of the denominator?
All right.
Cassett, what do you think, buddy? You with us?
Yeah.
I don't see Thomas on here actually. Peter, let me throw it over to you, buddy. Peter, what would it take to get rid of the radical in this denominator? I made up a new example here for you.
You have to multiply it by the one reciprocal or the other reciprocal, like the clever form of 1.
Yeah, that's what I'm asking. So, like, what is our clever form of 1? First of all, can we identify it's going to be a cube? Can we say cube root? All right, so we want the cube root of something.
4.
What do you think, Pete?
4.
All right, so the cube root of 4 times the cube root of 4 is going to give us a cube root of 16, not a perfect cube. We're looking for a perfect cube here. 4 times what would give me a perfect cube? And this is open to anybody now.
16.
16.
4 times 16. Okay. That'd be 64, which is a perfect cube. True that. Can I ask you this? Can you rewrite? There's a more efficient way to do it. Can you rewrite 4 as 2 times 2?
Yes.
4 times 2.
So what do you think now? The cube root, how many more 2's do we need?
2.
1.
We just need 1 more. So the cube root of 2 over the cube root of 2, and that's going to give me what I need. Cube root of 8, which winds up being 2. Hold on a sec, Mrs. Morgan's phone is ringing. We'll silence this. There we go. Put that on the vibrate. All right, no more distractions there. Sorry about that. But yeah, the whole idea is to figure out what's going to kill the radical, what's going to get rid of, in this case, the cube root, and it was to have a perfect cube. Now, if you had chosen, I don't know what y'all had said, like 16 or whatever, would that have worked? Absolutely, okay? But it would have made it more work on you. Like if you'd had the cube root of 16 over the cube root of 64. What's the cube root of 64?
4.
4. And lo and behold, the cube root of 16 is not simplified. You've got a perfect cube hiding in there where you would have to take out cube root of 8. You'd have to take out the 2, cube root of 2, and then that 2 and that 4 would simplify out, and you'd be left with cube root of 2 over 2, just like we did in green. So if you pick the smallest perfect square or perfect cube to get, then you're going to be sitting pretty. Okay. Now we're getting into the weeds a little bit. Let me bring it on home with a final example here. Okay. All right. And I've got about 3 minutes with you guys and I'll let you go. But look, this is the one where this separates the boys from the men as far as this particular topic is concerned. If you can handle a binomial denominator, then you're doing pretty good, okay? So I've got written up in red a property that we talk about multiplying conjugates. And again, I don't want you guys to be math robots, so this isn't just oh yeah, he showed me multiply by, whatever the radical is, so maybe I'll just multiply by square root of 3 over square root of 3 here, because that ain't going to get it done. Go in your own time, go ahead and test that out. Multiply radical 3. You got to do it times both of them, distribute it, and you'll still have 2 square root of 3 in the denominator. So that's not going to help you. But what's going to help you here is recognizing the fact that, oh, if I multiply a binomial times its conjugate, I'm lagging pretty bad. If I multiply a binomial times its conjugate, then the difference of squares is the result. And when I square a square root, that radical is going to go away. All right. So what would the conjugate cullen of my denominator be in this case?
2 plus the square root of 3.
That's going to be my clever form of 1. 2 plus the square root of 3. And this is where you guys really do have to shine in your creativity. Okay, because this is, algebra can be very doable if it's just rote memorization of steps, if it's just learn a basic process and continue to do that process the same way every time. And y'all are all good at that. Y'all wouldn't be in this class if you weren't good at, ooh, he can learn a process and he can rinse and repeat. But where you're really going to start to rise and where you're going to get pushed next year in honors geometry is going to be where you've got to be creative in your problem solving. So to where a teacher might not say, hey, by the way, use the conjugate here, but you'd be expected to think, how could I fix this to where the radical goes away? I put an equal sign there. I should have put a time sign, pardon me. How could I fix this so that the radical will go away? Okay. So check this out. When I multiply the top, that's easy. That's just 5 and then 2 plus radical 3. But look what the bottom becomes. It becomes 4 minus 3. Now, where on earth does 4 minus 3 come in? Well, just look right above you in red. Look at the difference of squares. That's a FOIL problem. That's a FOIL problem where you said, okay, 2 times 2, that's F. 2 times radical 3, that's O. 2 times negative radical 3, that's I. And then negative radical 3 times radical 3, that's the L. This one's going to generate a 4. These two are going to cancel each other out because they're conjugates. And then this one is going to generate a negative 3. So we'd simplify this down just to 5 and then the product, or the sum rather, of 2 and square root of 3. Because 4 minus 3 is 1, and that's cake at that point. Okay.
And you would
Now,
not want us to evaluate it?
If you distribute, you mean distribute, I think, Jack. If you distributed, that'd be fine as well. I wouldn't count off either way.
Mr. Morgan.
Matt.
I'm a little still confused. How did you do that one? Because I don't understand how that would be a FOIL problem in that.
All right, so like a FOIL problem is whenever you've got a binomial times another binomial. Okay. And like what you can do is you can break it down like I did into the basic like components like FOIL and just multiply the first times the first, the outer times the outer, that type of thing. Or since it's conjugates, like I think Cullen had told us they're conjugates, you could take the shortcut. You could say, hey, look, the O and the I are always going to cancel each other out when you're multiplying conjugates. So the result is just going to be, hey, square the first one. So in other words, square that 2. That gets you 4. Square the last one, square that radical 3, that gets you radical 3 times radical 3 is just 3. And then you got a minus sign in the middle because it's the difference of 2 squares. Okay. Now, I hate to leave you guys with this because this is going to take a little bit of practice. So here's what you're going to do. Okay. Here's what you're going to do. And I know our time is up, so I'm going to ask you 2 things. I can actually give you these 2 problems. Write these 2 examples down, and I want you to try them on your own. Okay, don't look up how to do it. Don't try and be, fancy that way. If you don't know how to do it, that's fine. That's not a problem. But I want to start our class tomorrow by talking about these 2 examples. Okay, 4 over 1 plus square root of 6. And then the doozy, the extra challenge, 1 over square root of 2 plus square root of 3 plus square root of 5. And if you guys will write those 2 down, then our lesson will be done for today. And I very much appreciate all y'all's hard work. And I look forward to seeing you guys again tomorrow. Okay.
Can you say those 2 again, please?
Yeah, do you not see them on my screen?
Your screen's frozen for me.
What's it frozen on?
I don't see it either.
Your face, and it just shows the background.
Has it been that way the whole time?
No, when you were explaining the FOIL problem, it was like that too. So that's why I was confused.
Man, that's weird. Okay, it's 4 over the quantity 1 plus radical 6. Okay, so 4 over the binomial 1 plus square root of 6. And then the next one is 1 divided by, and then the denominator is the denominator is a trinomial, 3 terms. So it's square root of 2 plus square root of 3 plus square root of 5. And that one will be, that's the butt kicker right there. That one will be the challenge.
Mr. Morgan?
Yes, sir.
2 questions. How are we going to take tests?
You're not going to.
Oh, we're not. Okay. And then, is your background Glacier National Park?
It is indeed. Good guess.
I went there last summer. It was really nice.
It's epic. That's been my favorite family trip that we've gone on. We spent about 3.5 weeks out there, and back in the summer of 2018, just driving around camping in different places. And so this was from going to the Sun Road in Glacier National Park.
We did that, and then we saw like on this kind of boardwalk type thing. There were a bunch of wild mountain goats, and they were just like literally right next to you.
Hey, if you hold on 1 second, I think I could pull this up pretty easily. Here. Oh, it's going to be slow. Oh, well. Let me scroll down to the P's. If you guys got somewhere else to be, you don't have to hold on for this, but I want to show this. This is one of my favorite pictures. As long as it cooperates.
Minecraft time.
Yeah, Microsoft Teams has made it such that you guys can pick your own backgrounds, and funny enough, they've got some Minecraft themes on there. All right, 2018, wake up. Oh shucks, I'll have to show it to you tomorrow. It's being goofy, I guess, but remind me. I'll show. Oh, here we go. All right, let's see here. We got to go all the way down to 2018. Where's the mountain goat picture? Teddy, we walked right. Oh, there it is. We walked right on up on this mountain goat when we were out hiking, and so I took a picture. He's literally like 5 feet away from that thing. Can y'all see that? Nice.
Did you go to Yellowstone?
Yeah, we loved Yellowstone. Yellowstone was legit, man. It was awesome.
The mountain goat, it was kind of like a pack. There were the ones that we saw. It was like, I think 2 females, 1 male, and there was 1 baby.
Nice. Yeah, my wife wanted to get bear spray. She was very concerned about running into some bears, but it was like $50 a bottle, and so I was like, we'll risk it. So thankfully we didn't get any bears. All right. Well, hey fellas, good class today. I will see y'all tomorrow and live Jesus in our hearts
Forever. Thank you, Mr. Morgan.
Look as good.